All right. And I'll record it anyways.
Hi. What the heck? How'd you do
That's
that?
that's David.
That's me.
Okay.
Sure.
Sorry, do we need a notebook?
Yeah, if you guys prefer to write it down, but I'm recording it anyway, so
I'd rather write it down right now because I'm not gonna do it later for sure.
Yeah, that's big boy facts right there.
okay, so remember this was a problem that we were working on, which was 3x minus 2y plus 4z is equal to 35. Then it was 4x plus y minus 5z is equal to negative 36. And then 5x minus 3y plus 3z is equal to 31. Okay, so these are, remember, if you just want to, just kind of a quick review of what we did, right? Remember that we took the top two equations and we eliminated y, right? And remember we did that by multiplying the middle one by 2, right? So we doubled everything so we can eliminate y. That's the first thing that we did. The second thing that we did is that we took the bottom two, so the middle and the bottom one, and why are you making trees, Desi?
She's artistic.
Incredibly distracting. Just kidding. But yeah, anyway, so what we did was we took those two middle ones, or sorry, those two bottom ones, and then we eliminated y again by multiplying by 3. So we tripled everything. That gives you positive 3y, negative 3y, and that cancels out those. Okay. So remember I had told you guys, remember I had told you guys to just kind of keep those in mind. Because what we're gonna do here, it ended up being negative 5x minus 6z is equal to negative 37, and then negative 7x minus 12z is equal to negative 77. Okay, so I had told you guys to keep this in mind because what we want to do is we want to eliminate another variable. Okay, so now we have those regular two equation systems or two variable systems that are a little bit easier to do. Okay, so looking at this, what is a good candidate for to eliminate?
Z.
Z. Okay, yeah. So Z is a pretty good candidate, right? Because to eliminate X, you know, between 5 and 7, how do we get from 5 to 7, or how do we get 7 to 5, right? But to get 6 to 12, what do we have to do?
Multiply by 2.
2. And not just 2, we have to multiply by a negative 2 because we need to make it a positive, right? So I'm going to write this down here. It's going to be negative 2 times negative 5 is positive 10x. Negative 2 times negative 6 is positive 12z. And negative 37 times negative 2 is going to be positive 74. Okay?
Oh my goodness.
So then I'm just rewriting the other equation down there. Okay? So good so far with that. So now what we need to do is that we need to combine them, right? So now we're gonna add them. And now our 12s cancel out. I forgot that's 77, but 74 minus 77, what does that end up giving us? That would be a negative 3. And then 10x minus 7x, what would that be?
3.
3x. Okay. And there we go. Now we've eliminated 2 variables and we're down to our final one, right? So now we just need to do what?
Divide by 3.
We divide both sides by 3. So x is equal to negative 1. So yay, we got one. We got x in our equation. Okay. And we still, we still need to work on all the other variables, of course, right? But what is usually our next step? What do we need to do to solve for the other variable?
Solve for y, you mean, or z, or whatever?
Well, in this case, we can solve for z because our variables are x and z in this system, right? So if we plug in a -1, then we can solve for z, right? So let's pick one. Which one would you guys want to do?
The top one.
So -5x, okay. So let me clear that. So we know that x is equal to -1. And then we want to plug it into -5x minus 6z is equal to -37. So what we're going to do is we're going to take x and we're going to plug it into our x, right? So -5 times -1 minus 6z is equal to -37. Okay. So now we're going to solve that. So we start with -5 times -1.
Isn't it just 5, right?
It's just a +5, yes. Okay. So then what's our next step there?
Move the 5.
We're going to move 5. We're going to subtract 5 on both sides. So that's -6z is equal to -37 minus 5, which ends up becoming -42. And finally, divide by -6. Z is equal to -42 divided by -6, which is going to be +7. And that is our Z. So now we have our X and now we have our Z. So now that we have both of those variables, what do you guys think we should do for the last variable?
Throw it in the trash.
Throw it in the trash? I mean, that might work. I'm not sure. So we already know that X is equal to -1. We already know that Z is equal to 7. So
Would you plug them in?
So if we plug them in, yes, if we plug it into the original equations, right? So one of our 3 variables. And I can pick, what I'd rather do is pick the middle one, right? Because y is already by itself, right? So if y is already by itself, that's probably the easiest one to go with. So that equation was -4x plus y minus 5z is equal to -36. Okay. So we get to plug in now that we know our two of the 3 variables, right? So -4 times -1 plus y, and then -5 times 7 equals -36. Okay. So now it becomes a little bit easier, right? It's just -4 times -1.
It's just 4.
+4. And then -5 times 7, which is
48.
actually 35.
35, yeah, negative
Right.
30.
Okay. All right, so, well, we can combine our like terms there. That's 4 minus 35. Oh, sorry. So y minus 31. And now let's just solve that. which means that we're going to add 31 on both sides. So y, that cancels out, y is equal to negative 36 plus 31, which is
-5.
Yeah,
negative
negative.
5. Exactly. Okay, so we got it. Y is equal to -5. So the answer here, -1, -5, and 7. A lot of work, but yeah. And well, of course, like, I guess the idea is that, you know, the applications here is that usually when we're looking at X, Y, we're just looking at a simple graph like this, right? That's in 2 dimensions. That's in 2 dimensions, right? When we add a Z, that would be sort of our 3rd dimension, right? So we just kind of add an extra axis there, right? And we work in 3 dimensions. And so one of the things when I was at UTEP, when I was first doing engineering, we were learning a program where we're basically working in a 3-dimensional scale. So we were using graphs like this where it was X, Y, and then Z to make it a 3-dimension. And so that's kind of the idea where, like, sort of, I guess, 3 variable systems kind of come into play. But of course, there's a lot of applications, especially for like coding and things like that, where you might be looking into like a business to optimize profit or something like that. So there's a lot of applications that we usually do with that, you know. But of course, that's a pretty advanced thing to do if you're pursuing something in those areas, which I know that most of us aren't, but it's okay. All right. But anyways, so I take a picture of your drawing before I take it off, Desi.
Sorry, I said it's still easier to use calculators. I'm just saying.
Well, of course it's easier to use calculators, but you know, I want you to use that noggin of yours.